Thank you. Thanks for that, Lydia. I enjoyed that trip down memory lane with wingdings and dingbats. Now, I remember there was the designer, David Carson. He worked, I think it was at Wallpaper magazine, like in the 80s when it was all desktop publishing. And somebody had done an interview with Brian Ferry, and David Carson decided the interview was just so boring. He typeset the whole thing in dingbats. So like the magazine went out and the whole thing was just complete gibberish. Good morning. Lovely to be here. You're all looking lovely this morning. This is my first time in Stockholm, so a real pleasure to be here. So this morning, I'd like to kick things off with, I'll kick things off with a story, or rather a creation myth. You may have heard the story before that, the internet was invented to withstand nuclear attack, right? It's not true. What is true is that Paul Baran at the Rand Corporation, he was worried about this possibility of, a single point of failure in military communications. And in his investigations, he came up with the idea of packet switching. This idea that you would break a message down into multiple packets, send those packets through whichever route is fastest, and then put them together again at the other end, right? And this idea of packet switching, which is a very resilient way of building a network, that caught the eye of Leonard Kleinrock. Now, Leonard Kleinrock was over at ARPA, the Advanced Research Projects Agency, and they were working on the idea of a network, and they did want the most resilient network they could find. So this network was the ARPANET, and to begin with, it was very small indeed. It grew bit by bit over time, but the first message sent on this network was in 1969. It was at 10:30 p.m. on October 29th, and it was a message sent from UCLA to Stanford. And it was a very simple message. It was just one word, and that word was log in. So the command was sent from UCLA, and the system crashed after 2 characters. So this was the first message ever sent on the ARPANET, low. But they fixed the bugs, and this network started to grow over time, and more nodes were added to this network over time, and more networks were added to this network. It started to get a bit out of hand. So the important thing became that these different networks, this network of networks, could all understand each other. They needed a common language for passing these packets around. Well, enter Bob Kahn and Vince Cerf. Right? They came up with this idea of the transmission control protocol and the internet protocol. This is when the ARPANET really started to morph into the internet, when we started to get these low-level protocols for passing these packets around. Now, at the time, Bob Kahn and Vince Cerf, they weren't worried about making a network resilient to nuclear attack or anything like this. These were idealistic young people. They were concerned with making a network that was resilient to any kind of top-down control. Right? The whole point of this packet switching network was that it wouldn't favor any particular kind of packet over any other packet. In fact, I think that's the secret sauce of the internet, is that it's a dumb network, right? Deliberately so. That the network doesn't care about the contents of those packets being switched around. All the intelligence lies in the nodes, not in the network itself. So that's the underlying idea behind TCP/IP. It's the simplest possible protocol for passing these packets around. They used to joke at the time that you should be able to implement TCP/IP using 2 tin cans and a piece of string. Now, once you have this low-level protocol, you can then build slightly more complex protocols on top of that, as long as everyone underneath is still using TCP/IP. And that's what happened. People started switching their protocols over to using TCP/IP. So you've got Telnet, Gopher, right? Protocols for sending email, file transfer protocols. And you could just make up a protocol. You didn't have to apply, you didn't have to ask for permission. You just could start making up a new protocol tomorrow if you wanted. The trick is getting people to use your protocol, right? You want to benefit from Metcalfes Law, right? Bob Metcalfe, the inventor of Ethernet, and his law was that the value of a network is proportional to the square of the number of users connected, something like that. Basically, the idea is the more people use your network, the more powerful the network is. Like, the first person who had a fax machine had a completely useless machine, right? But as soon as one other person had a fax machine, it was exponentially more powerful. So this was the situation where you got this low-level protocol, TCP/IP, at the bottom, and anybody is free to create other protocols on top of it. You just have to convince people to use your protocol. And that was the situation when a new protocol appeared, the Hypertext Transfer Protocol. And the Hypertext Transfer Protocol was one part of this three-part stack that formed the World Wide Web project. Right? You got Hypertext Transfer Protocol, that's the protocol level. You got URLs for identifiers, and this very, very simple format, HTML, the hypertext markup language for the resources that you can have at the end of those URLs. And this project was the brainchild of young computer scientist Tim Berners-Lee. And what I loved about it was, even when this was just one computer running this project, Tim Berners-Lee's next machine, he still called it the World Wide Web. Right? I mean, that's confidence. And the situation was that Tim Berners-Lee was working at CERN at the time. Now, CERN is this absolutely amazing place. It just blows my mind. It's, the most complex machine ever built is this Large Hadron Collider under the border of Switzerland and France. Recreating the conditions from the start of the universe as they spin up these protons moving almost at the speed of light, smash them together, and then try and gather the data. Really amazing stuff. It's also a place where you've got people from all over the world collaborating, and there isn't really much of a hierarchy there, right? And so you can't dictate to the scientists, you must all use this operating system, or you must all use these file formats. People are allowed to use whatever they want. And this was kind of the problem that Tim Berners-Lee was trying to solve. Is like, you got all these people using all these different kinds of computers, different kinds of formats. How can we share information together? And he approached it from this hypertext idea, which wasn't his first time building a hypertext system. He'd actually, in the early 80s, built a system called Inquire, or the full name was Inquire Within Upon Everything. It's named after this Victorian book of manners, which I always thought would be a great name for the internet, right? Inquire Within Upon Everything. But Inquire didn't really work out, but it got some ideas from it. And so, 10 years later, he put together this proposal, really quite boring title, Information Management, a Proposal. He puts this forward at CERN, but his boss, Mike Sendall, must have seen something in this proposal, because he scrawled across the top, vague but exciting. So Tim Berners-Lee gets to go ahead, the web is built, and we've got the web we have today. Good job, Tim Berners-Lee. But it wasn't an accident, right? It wasn't a foregone conclusion that the web was going to take over the world. Now, Tim Berners-Lee was well aware that, you have to convince people to use it. And he realized that the way you do that is you make sure it's as simple as possible. It's like that apocryphal Einstein quote, right? Make it as simple as possible, but no simpler. And if you look at those building blocks of the World Wide Web project, I think that's true. Like, all these pieces, they're not great, right? HTTP is not the best protocol, and HTML is not the best format. URL is, not the best identifier necessarily. They've all got flaws, but they're all just simple enough, but just powerful enough that people get started with them pretty easily. And this turned out to be, really important to the adoption of these technologies. I mean, take a look at HTML for a start. To begin with, there was no HTML version 1. There was no official spec. There was just this document called HTML tags, presumably written by Tim Berners-Lee. And it was just this one page that contained the entirety of HTML, which at the time was 21 elements. 21 elements, that was it, that was HTML. And even those 21 elements, Tim Berners-Lee didn't come up with. He didn't invent them. He stole them wholesale. There was an existing format, a version of SGML, being used by the scientists at CERN. And because he knew that this would be familiar to people, that there was more chance of HTML being adopted. They would look at this and go, oh, right, the whole angle bracket thing, and I recognize this P and H1 and UL and LI, right? So he was able to get that adoption, because instead of trying to completely change people's behavior, he was just nudging the behavior. Now, you compare that first official stab at HTML with 21 elements to what we've got today, where we've got 121 elements. But it's still the same format, which I find kind of amazing. How do you have a file format that's managed to grow from 21 elements to having 100 more elements, and yet still it's the same format? I mean, if you know anything about computer formats and digital preservation, it's unheard of that you have the longevity of something like HTML. It's been longer than 20 years now, right? That's crazy. I mean, if you took a word processing document from 20 years ago and tried to run it today, you would have a bad time. And yet you can take HTML from 20 years ago and it will totally be parsed in a browser today. That's kind of amazing. Now, I think there's a design decision in HTML that has allowed it to expand over time, to go from 21 to 121 elements. And that's to do with how browsers parse HTML. I mean, if you think about what a browser does when it comes across an HTML element, you've got the opening tag, the closing tag, maybe there'd be some attributes on that opening tag, right? And you got some content in between. Well, the browser displays the content in between the opening and closing tag. Depending on the element, it might do some other styling stuff maybe, or maybe some behavioral stuff, but the default behavior is, oh, I just show that content in between the opening and closing tag, right? You all know this. But what's interesting is when you give a browser an HTML element that doesn't exist, right? You give it something it doesn't understand, it still shows the content. What's interesting about this is what the browser does not do. The browser does not throw an error, right? The user doesn't see an error pop up saying there's a problem with this document. The browser does not stop parsing the HTML at this point and refuse to parse any further. No, it just sees a tag it doesn't understand, ignores the tag, renders the text in between the tags on screen. Well, that design decision, that turns out to be hugely, hugely powerful. That's how we get to add new elements. Right? This is how we grow from 21 to 121 elements. It's because we can create new elements and yet know that there won't be a problem with older browsers that don't understand these new elements because we know what the behavior will be. In fact, we can use that behavior to our advantage. When we create a more complex element, something like Canvas, right? And we know, wait a minute, if we know that older browsers are going to display whatever's in between the opening and closing tags, then let's use that. Let's say you can put fallback content for older browsers in between the opening and closing tag, and newer browsers that do understand Canvas know that they shouldn't show what's in between the opening and closing tags, right? Now that's not an accident. The Canvas element started life as a proprietary element by Apple. This is how a lot of standards actually happen, is that, you know, one browser maker will just invent something, other browser makers go, ooh, that's good, and it gets standardized, right? And that's what happened with Canvas. Apple created this completely proprietary thing, and later on it got copied by other browser makers and standardized. But when it was invented by Apple, it was a standalone element, right? Like the image element. It didn't have a closing tag. And in the standardization process, they made sure to give it a closing tag, specifically so authors could do this fallback content in between the opening and closing tags. And you'll see a similar thing with things like video and with audio, right? This is not an accident. Another design pattern I kind of like is if we look at the image element, and the history of the image element is kind of fascinating because, you know, in that first version of HTML, there was no image element. It was all text. And there was this mailing list, www talk, where people making web browsers would get together and talk. And at this time, like, every single person on the web was making a web browser. It's like, it was the done thing. And they were discussing this possibility of having some kind of image embedding inside HTML. And they're discussing, saying, well, maybe it should be called object because it might not be just images. One day, maybe people put video on the internet, who knows? And then icon was another name that came up. So they're debating this backwards and forwards. And then Mark Andreessen, who was making the Mosaic browser, he writes an email saying, guys, I've just shipped it. It's called IMG, and you give the source of the image in this src attribute, and it's going into Mosaic. So everyone else in the mailing list went, okay. Because it was kind of that sort of motto of the IETF, right? Rough consensus and running code. They had rough consensus about what they needed, but more importantly, they got running code. That trumps it. That's what gets launched. But it's not a great pattern, right? Because it doesn't have that closing tag, so we don't get to put that fallback content in between an opening image and a closing image tag. So we end up having to use this alt attribute to have this alternative text. It's not ideal. But the image element works for a while, you know, except there's always been this kind of inherent clash between the flexible nature of text on the web, it doesn't matter what your browser window is, and this really rigid, you know, width and height of bitmap images on the web. But we got by for a while till, you know, responsive design came along. Thanks, Ethan. And we had to deal with, how do we deal with images, you know, fixed width, fixed height images in this fluid, flexible world of the World Wide Web. Well, this is where we got the source set attribute, right? Now, I really like the design of this. So the point is that you could give the browser other images inside the source set. You say, well, there's one that's twice as big here, and there's another one that's 3 times as big over there. You let the browser decide which image it wants to use. But the way that this works is that what the source set attribute does is it kind of updates the value of the source attribute. And what that means is you can't leave off the source attribute. You have to include the source attribute or it just won't work at all. That means backwards compatibility is built in. Older browsers that don't understand source set will always still get source because you can't leave it out. And it's the same with all the other responsive image stuff we got, this picture element. You think about how an older browser is going to see this, it's going to see it as an image element with a source attribute. And yet we can use all this new stuff in the newer browsers, reward the newer browsers, right? So there's been real thought has gone into these patterns as HTML has evolved to ensure there's backwards compatibility along the way. And crucially, it's because of that error handling, that we know we can add stuff like this to the image element, we can add stuff like this to HTML, and we know how older browsers will behave. They won't throw an error, they will just skip the stuff they don't understand and move on. And it's pretty much the same with CSS, right? You got this very powerful way of styling pages that has grown enormously over the years. If you stop and think about all the websites out there using CSS, which is pretty much all of them these days, right? And how different they are, how different they look, right? How the designs vary. And then you think about how all of that boils down to one pattern, and it's this pattern. You got a selector, property, and value. That's all the CSS that's ever been written. And I find that kind of mind-blowing, kind of beautiful that it's so simplistic. A couple of special characters, curly braces, semicolons and stuff for the machines to parse it, but ultimately, this is all of CSS. The tricky thing is knowing the vocabulary of the selectors and the vocabulary of the properties and the vocabularies of the values, right? But ultimately, this is all of CSS. And that's allowed CSS to grow over time because a browser parsing CSS, if it sees a selector it doesn't understand, it doesn't throw an error. It doesn't refuse to parse the rest of the CSS file. It just skips over the curly braces, right? If you give it a property it doesn't understand, it just skips that particular declaration. Same if you give it a value it doesn't understand. It just skips over it, goes on to the next thing. So that's enormously powerful. That means we can add to CSS over time. And again, we know it's not going to break in older browsers. They'll just skip over the bits they don't understand. It's hugely, hugely powerful. It's interesting with looking at the history of CSS. I think if we look at, say, the last 5-6 years of CSS, I'd say there's been 2 major differences in how we approach it. One is using things like pre-processors and post-processors, right? Stuff like less and Sass and all that. Who uses a pre-processor or post-processor when they write CSS, right? It's become the norm. The other interesting development has been, people coming up with systems for their CSS. Things like Objectoriented CSS and BEM and SMAX and all these different ways of writing your CSS. Now, the reason why I find this interesting, these 2 developments, is that in both cases, things like preprocessors or whatever we want to call these approaches to CSS, we didn't have to go to the standards bodies. We didn't have to go to the browser makers and say, please implement this. We were just able to do it. In the case of preprocessors, because it's sitting on our machines as opposed to being something on the client. And in the case of these approaches to CSS, like BEM, we're basically just having an agreement about how we're going to write our CSS. And actually, even simpler than that, it's really just about how we're going to write our selectors, right? It's just about the stuff outside the curly braces. And why I find that interesting is that nothing new happened in CSS to enable that. We could have been writing BEM 15 years ago, right? That this very, very simple pattern was able to reveal something so groundbreaking after all those years, and yet nothing's changed in the pattern. I find that really interesting. It makes me wonder, what else has been staring us in the face for all these years that we're missing? That there's possibilities buried in these very simple technologies that we're not taking advantage of. And that's something I want to come back to. But so ultimately, this resilient nature of CSS and HTML, the way they're able to expand over time, the way they're able to have backwards compatibility built in, is because of this fault-tolerant error handling. It's the fact that they don't choke on stuff they don't understand, and they just carry on parsing. They recover from errors very well. Now, I see this as an example of Postel's law, John Postel, he was working on the ARPANET. He was figuring out, about all the packet switching stuff. And he came up with this that's also known as the Robustness Principle, right? Be conservative in what you send, be liberal in what you accept. Now, he was talking about packet switching, right? If you're sending out a packet out in the network, make sure it's as well formed as it can be. But if you receive a packet and it's badly formed, but you still understand what you're supposed to do with it, don't be a dick about it. Just pass it on, right? Don't go, oh, I refuse to parse that. Be liberal in what you accept. Now, Postel's law, you might think, right, that's an engineering thing, right? It applies to networks and packet switching. But I see it at work all the time. Like in the world of design, UX. If you're building a form on the web, right, and you're going to put that in front of a user, well, first of all, it's like, use as few form fields as possible. Right? Be conservative in what you send. And then when the user is filling in that form, right, don't make them format their credit card number or their telephone number in a certain way with spaces or without spaces. No, be liberal in what you accept. So I see Postel's law everywhere, and I certainly see it with the way that browsers behave when it comes to CSS and HTML. It's an implementation of Postel's law. Now, I think that CSS and HTML can get away with this loose error handling because they are declarative languages. Right? With a declarative language, you don't get to instruct the computer exactly what it should do. It's more like you declare what your content is, or you declare your desired styling, and then you leave it to the computer to do with that as it will. So you don't get as much power with a declarative language as you do with an imperative language. But what you do get is this resilience built in, because these declarative languages can afford to have this lax error handling. Now that's very different to something like JavaScript, which is an imperative language, where you do get to instruct the computer and say, I want you to do this exactly, and then do that. Now, an imperative language like JavaScript, you can't have that same lax error handling. It would be really, really hard to program in an imperative language if the computer, every time you made a mistake, the computer's like, don't worry about it. It's like, that's not helpful. I need you to tell me when I'm making a mistake. But it comes at a cost, right? So you get much more power with an imperative language because you get to control things precisely, but it's a bit more fragile. It doesn't have the same resilience as a declarative language. So in a web browser, we're talking about client-side JavaScript here, you have this sort of three-tiered stack, but there's a fundamental difference between that level at the top, the JavaScript, and the levels below, because JavaScript is imperative, therefore a bit more fragile, yet more powerful, and CSS and HTML are declarative, much more resilient, able to recover from errors, not quite as powerful in what you get to do with it, right? If you look at the history of the web, though, what I find interesting is that we tend to figure stuff out at the top level, at the imperative layer. Like, we've got a problem, we need to solve it, we're going to hack together a solution in JavaScript till we got it working. And then that solution will find its way further down the stack. Right? It'll move into the declarative layer over time, it'll get standardized, and get the benefit of that resilience, that lax error handling. Like, when JavaScript was first invented, showing my age here, but there were two main uses of it. First was image rollovers. Right? You'd mouse over something and it would swap out one image for another. And the other big use was form validation, that when you hit submit in that form, it said, no, that this field is required, or that doesn't look like an email address. Now, these days, we wouldn't even use JavaScript for those use cases, right? I'd use CSS to do, hover animations. And I'd use HTML, things like the required attribute or type equals email, to do that form validation. So those patterns were solved in JavaScript, and then they moved down the stack into the declarative layer. Same with the responsive images solutions, right? We had these polyfills and these hacks, and then they get standardized and they move down the layer. So there is this trade-off, definitely, between the resilient declarative language and the more fragile and imperative language. So interestingly, there was a period where we almost got the worst of both worlds. Trigger warning, XHTML2. So this was about 10 years ago when the W3C decided HTML was dead, XML is going to rule the world, let's move HTML over to being XML. Now, you might remember XHTML version 1. That was fine. That was just HTML reformulated according to the syntax of XML. And the syntax of XML is all your tags must be lowercase, all your attributes must be lowercase, all your attributes must be quoted, right? Because in HTML, it doesn't matter. You can have uppercase, lowercase, quoted, unquoted, doesn't matter. So XHTML1 was just saying, if you want to write XHTML1, you have to make sure that you're using the syntax from XML, where everything's nice and neat. And that was kind of nice. It was actually a way of enforcing a consistency in the way we wrote HTML. That was fine. But XHTML2, well, first of all, it was going to completely change the vocabulary of HTML and get rid of things like the image element, right? Start from scratch. But also it was going to borrow the error handling model from XML and apply it to HTML. And the error handling model of XML is this. If there is a single error anywhere in the document, do not parse the document, right? So one unencoded ampersand, no, the user sees nothing, right? Seems kind of crazy, and it was crazy. I mean, the idea that you would put something so fragile on the public web in front of users that could break so easily, it was crazy, right? And we developers, designers, we rejected it. We said, that's nuts, we're not going to do that. There was this rebellion with HTML5 to keep the lax error handling of HTML going. We rejected the draconian error handling of XHTML2, rightly so. And yet here we are, 10 years later, and we're building everything with the most fragile layer of the stack. Rendering text to a screen, instead of using something declarative and resilient, we decide, no, let's use the most fragile bit. JavaScripting all the things. I'm not saying don't use JavaScript. I love JavaScript. Big JavaScript fan. I'm saying it's how you use JavaScript. How you layer it on top of something that's already there. I remember a few years ago when the page for downloading Google Chrome stopped working. Nobody in the world could download the Chrome web browser. And the reason was because there was an error in a JavaScript file, probably completely unrelated to this, but in the HTML, this link to download the Chrome had been written like this. So effectively, the imperative layer had been pulled down into the declarative layer, so you get all the fragility of that imperative layer inside something that should be more resilient. Presumably heads rolled over this, right? Because the error handling model of JavaScript is if there is an error, you throw an error, and you do stop parsing the JavaScript file at that point and refuse to parse any further. So that's very different to CSS and HTML. And that's okay as long as you understand that and you build that in mind, but let's not pretend that, well, rendering to the screen with HTML, rendering to the screen with JavaScript, what's the difference? There's a big difference, and it's to do with this error handling. And you might think, that's fine, I build things the right way. Nothing's going to go wrong with my JavaScript rendered text on a screen. Which brings us to another law that I think is as important as the Robustness Principle, as Pastel's law, and that's Murphy's law, right? That anything that possibly can go wrong, it will go wrong. Murphy was a real person. He was an aerospace engineer. And because he had this attitude, nobody died on his watch. I think we need to acknowledge Murphy's law when we're building on the web instead of sticking our fingers in the ears and going, no, everything's fine, my JavaScript's going to run fine. Stuart Langridge put together this kind of list, this flowchart of all the things that can possibly go wrong with JavaScript. And some of it's on the client side, some of it's on the network in between, ISPs messing with packets. Some of it's on the server side, right? The things go wrong. The point is, if something goes wrong with your HTML and your CSS, it's not so bad because of that error handling model. It's going to recover probably okay. But if something goes wrong with your JavaScript, depending on how you're using that JavaScript, it could be catastrophic. I think we need to acknowledge this, right? In the same way that other industries do. Car manufacturers, they test their cars in extreme conditions. They strap in crash test dummies and smash them against walls. I mean, could you imagine if car manufacturers said, we've been thinking about this, and we're not going to do this whole strapping in crash test dummies and smashing cars against walls anymore, because we've realized that actually our cars aren't going to be driven by crash test dummies, they're going to be driven by people. Also, we think these people will drive on roads, not smash into walls at high speed. Which, yes, of course, you hope that that's what's going to happen. You want to hope for the best, but you still got to be prepared for the worst. And I think we need to be prepared for the worst on the web, particularly because the web is, frankly, a fairly hostile environment when it comes to distributing software, right? What was it Douglas Crockford said, like the most hostile development environment there is? My friend Trent Walton, he's a designer in Austin, he made this comparison as well. He said, like cars designed to perform in extreme heat or on icy roads, websites should be built to face the reality of the web's inherent variability. The reality of the web's inherent variability. That's never going to change. right? The one prediction I can make about the future of the web is that diversity is going to increase. We'll have many different platforms, many different browsers, many different devices. I feel fairly confident in that. And we need to acknowledge that those different devices, different browsers, different platforms have differing levels of support for different things, right? Whether it's to do with web fonts, JavaScript, CSS, HTML, we need to acknowledge the web's inherent variability. Now, this might sound very doom and gloom, like saying, oh my God, this is the way we're building the web is terrible and we're all doomed. No, 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 no. I did not come just to bring problems. I offer a solution. I offer a three-step solution in how I approach building for the web, and I'd like to share it with you. Step one, I'm building for the web. I identify the core functionality, not all the possible functionality, the core functionality of the thing I'm building. Then I make that core functionality available using the simplest possible technology, not the best technology, not the fanciest, just whatever's the simplest. And then I enhance from there. And this is where you want to be spending most of your time, right? This is where the fun is. But steps 1 and 2 are important to set the groundwork so that you get to go crazy at step 3. I'll illustrate what I mean. Identifying the core functionality. Now, again, this isn't about identifying all the possible things users might want to do with your service. It's about identifying that one thing that all users should be able to do with your service. What's your core premise? So let's say you're a news provider, right? You provide news. Well, that right there is your core functionality, is providing the news. And notice, I'm not saying anything about the technology here. This is just about what do users want from my service. So providing the news is the core functionality for a news service. Let's say you're making a social network where people can send and receive messages no matter where they are and stay in touch with people. Well, that right there is the core functionality, the ability to receive messages and the ability to send messages. And again, we're not even thinking about the technology here, just the core functionality. If it's a photo sharing service, well, the clue is in the name, the ability to share photographs. I expect to be able to see photographs. I expect to be able to share a photograph with other people. And if you're building some kind of productivity tool that allows people to write documents, collaborate with other people on documents, that's the core functionality right there. Be able to write, edit, share documents. Okay, so it doesn't take long to establish what's the core functionality. And you've got to, stop yourself from thinking about all the other cool stuff you could do. It's like, wait, not yet, not yet. Just what's the core functionality? And once you identified that core functionality, you then make it available using the simplest technology, not the best technology, the simplest. The reason why you want it to be the simplest is because that simplest technology has more chance of being available to the widest number of people. So if I'm putting news online, I guess the simplest way of putting it online is to mark it up in HTML. I mean, technically, the simplest way of putting it online would be a plain text file, but I'll level up slightly and say markup. Okay, a marked up document with the news, done. If I'm putting a social network online, we identified the core functionality as being able to see messages, so probably a reverse chronological order list of messages, and the ability to send a message. So this is where forms come in, right? Type in a message, hit submit. Very similar with the photo sharing service, except this time the reverse chronological list probably wouldn't be text, it's going to be images, and we have the image element. So this, at this point, that's the simplest possible technology for displaying images, and forms again for the sending of images. It's slightly different this time because it's input type equals file instead of input type equals text. Okay, but that's the simplest possible technology. And you send that off to the server, store it in a database, do all that stuff, right? Not sexy, but it's the simplest possible technology. Something like a writing app where you're going to be able to write, edit, and save documents, well, forms again, a text area. That's the simplest possible technology. Now, if you built those services like that and you stopped at that point, I wouldn't hold my breath waiting for the IPO. The user experience would frankly suck. But what you will have done is made something available to the widest possible number of users. The trick is that you don't stop there, that you go on to level 3. Level 3, enhancing, that's where the fun happens. That's where you get to go crazy. And because you spent time at levels 1 and 2 making sure that the core functionality is available to the widest number of people, you can go absolutely crazy at level 3. You can start using the latest APIs. Maybe they're not supported in every browser. Doesn't matter, because everyone is going to get your core functionality. So for a news website, we've marked it up in HTML. Well, we'll add layout to that. Now, it might be weird to think about layout as an enhancement, right? Putting things into columns on wide screens. But if you think about responsive design, and particularly mobile-first responsive design, whereas you get, as the screen gets wider and you're adding in more immediate queries for how things should be laid out, you're effectively treating layout as an enhancement, right? And we can make it look beautiful with web fonts. And again, web fonts are very much an enhancement. You know, I love typography. I wish I could say that web fonts were a requirement. But the reality is, you know, people can disable fonts. You know, it's built into ad blockers these days. Older browsers aren't going to get your web fonts. That's OK. It's an enhancement, a beautiful enhancement. In the case of this social network, we'll be able to see messages, we're able to send messages, but it's a pain, right? Every time we send a new message, it's a full page refresh as it goes back to the server. So let's improve that with some Ajax. That, you know, when I type a message, hit send, we don't have to refresh the whole page, we just refresh the bit of the page that's updated. And we could go further, we could use technologies like WebSockets, so that as new messages arrive, I'm getting those updates in my browser without the full page refresh. You know, maybe not every browser is going to support this. It doesn't matter. It's an enhancement, right? This is layered on top. And when I say it's an enhancement, don't misinterpret this as me saying it's just an enhancement. The enhancements are, you know, where the fun is and where the differentiation lies. The enhancements are what's going to separate you from the competition. In the case of the photo sharing app, all the other stuff we've said so far, right? So we've got layout inside media queries, we got typography, we're going to have Ajax, we're going to have WebSockets. Let's go further. What can we do? We're dealing with images here. Well, there's the file API, that we can do stuff with that file even before it goes to the server. We can have fun with it. What can we do? Well, we can start applying CSS filters. You know, add that nice sepia tone to those images. And again, it's like, oh, the browser support is not quite there yet. Doesn't matter, right? Because the core functionality is available to everyone. So you see how this starts to allow you to play with the latest and greatest technology without having to think, oh, I can't use that because not every browser supports it. This is a way of allowing you to go crazy with this stuff. And in the case of the writing tools, we've already got Ajax, and we got Layout, we got WebSockets, we got all this good stuff going on. What can we add on top? Well, let's make sure we're not reliant on a network, that we can start storing that stuff locally in some kind of local storage. And man, you've got many options these days when it comes to local storage, so go crazy, whatever your client-side database of choice is. And we can make sure that we're not completely reliant on a network by using things like service workers. Service workers are awesome. I think you'll be hearing more about service workers over the next 2 days. It's probably the web technology I'm most excited about right now. This allows you to script how the browser should behave when it's offline. So you can literally start to treat the network itself as an enhancement. It's hugely powerful. So this 3-step process, what I like about it is that it's scale-free and that it works at different scales. So I've only been talking about it at the level of your entire service. Like, what's the core functionality of the entire service you're providing? But you could go narrower. You could look at it at the level of a URL. Right? Well, on this particular page, this particular URL, what's the core functionality? How do I make that core functionality available with the simplest possible technology, which probably involves old-fashioned client-server stuff, right? And then, how do I enhance it? And you could go deeper still, right? We're all getting into our modular designs these days, making everything a component. Well, you could apply this 3-step process at the level of a component and say, what's the core functionality of this component? How do I make that functionality available with the simplest possible technology, and then how do I enhance that functionality? So, you know, the component might be an address. Here's where you can find us. Well, the simplest possible technology is text on a screen saying, here's our address. And then you could level up and go, actually, I'm going to enhance and turn it into an image. It'll be a map. And then you can enhance further and make it a slippy map, right? And you can enhance again and give it animations and drop shadows and put all sorts of fun stuff on it. So, the key thing here is that you're not having to choose between this false dichotomy, that you either have the basic functionality or you have the rich interaction. I'm saying you have both, and not at separate URLs either. I'm saying the same document is simultaneously something that works everywhere with the simplest possible technology, and it is also something that's using the latest and greatest APIs and rewarding the newest browsers. Now, there's a myth, I think, about this. The myth being that, oh, if I'm considering, you know, older browsers and how they're going to behave with my app, my product, that means I'm going to be spending all my time in older browsers. And actually, it's the complete opposite, because you don't spend that long on steps 1 and 2. You spend most of your time on step 3, the difference being that you spend that time on step 3 secure in the knowledge that you know exactly how all the browsers are going to behave. They're going to skip over the stuff they don't understand, and they're going to get the very simple experience, the old-fashioned client-server experience. So this kind of allows you, gives you permission to play with stuff and have fun at level 3. Now I get some pushback on this, and it falls into 2 categories. The first category is when people go, this is too easy, or rather, it's too simplistic, or too naive, right? It's not realistic. This is not realistic to expect me to have to do this. People say, well, this might work for a simple website. This will work for your simple little blog, but it's not going to scale to this big organization that I have and this really complex app that I'm building. Now, it's true. There are definitely some things that I think answering that question, what's the simplest possible technology, still gives you a technology that's a pretty high bar. If you're building a complicated game in the web browser, the simplest possible technology might well be something like WebGL, right? It's kind of hard to imagine applying this process for a game. Although I would love to see a game that begins as a text-only adventure, but then gets enhanced up to a third-person shooter. That would be kind of cool. But what's interesting about this pushback, that this isn't realistic, that this is naive, is that I've heard it before. That when we were making the switch from tables for layout to using CSS for styling, people back then were like, yeah, okay, that's fine for your little blog, but it's never going to scale to this complex site that I'm building. And then, Doug Bowman launched Wired.com with CSS, and Mike Davidson launched ESPN.com with CSS, and the floodgates opened because I've been shown, oh no, you can actually do this. And when responsive design came along, right, and Ethan said, hey, this is how we can accommodate both small screen browsers and large screen browsers. And people said, well, Ethan, that's fine for your little blog, that's fine for a simple site, but it could never possibly scale for a complex organization. And then the Boston Globe launched, right, and showed that it was possible. And then the floodgates opened again. So there's an opportunity here for you to demonstrate that this scales, that for you to make something that works, perfectly fine in a simple proxy browser like Opera Mini, but then works amazingly in the latest browser using all the latest APIs, right? Don't dismiss it. Now, the other pushback I get, instead of people saying, oh, this is too easy, people say, no, this is too hard. They take a look at those steps and they go, wait a minute. You're saying I'm supposed to build my service using the old-fashioned client-server model, and then when I start on step 3, I'm going to have to just recreate all that functionality again, but in the client? Right? I have to write all that logic that I've already written on the server or on the client. It's like, maybe, depending on how you've structured it. I mean, I know people are onto the universal jobs. Is that what we're calling it now, or isomorphic? I lose track of what the buzzword is. But the idea that you could literally have the same code base on the server and the client, that offers some hope there. But fundamentally, I think it's fair enough to say this is going to take more time. It's true. It will take you more time at first. Right? The first time you try building this way, if you're not used to it, it's going to be hard. I'm not going to sugarcoat it. But the second time, it's going to be easier. And the third time just becomes normal. And again, that's what it was like when we switched from using tables for layout to CSS. The first time I tried using CSS instead of tables, it was hard. I didn't know what I was doing. It took me a long time. Second time, it was hard, but I knew what I was doing a bit more. And then it just becomes normal. Now I couldn't build a site with tables for layout if I tried. And with responsive design, all right? First time you tried to make a responsive website, pain in the ass, right? You're not used to building in a fluid way. It's hard to change. But then the second time is a bit easier, and then the third time easier again. So it gets easier. It will take a bit more time first time you try it, but it gets easier. I say, don't dismiss it. The way I approach this is that by spending a little time with steps 1 and 2, you've got the safety net for you to go crazy at step 3. You know the way we talk about technical debt, the way that some decision that somebody made in the past is really biting us on the ass now, right? Well, I think of this as technical credit. You spend a little time making sure it works for everyone with the simplest possible technology, and you've got technical credit that you can spend step 3. But I do see pushback, and it worries me because when I look at the reasons for the pushback, why people don't want to approach building this way, what I see is there's people really valuing developer convenience. That's the most important thing. This looks hard, so I don't want to do it. And that's fine. I value developer convenience. I'm a developer. I want things to be as easy as possible, right? I'm not a masochist. But a lot of the expensive user needs, right? We need to have priorities. My priority is definitely going to be user needs over developer convenience. If I'm faced with a problem, and I have the choice of making it my problem or making it the user's problem, I'll make it my problem every time. Because that's my job, right? That's why it's called work. But we tend to have this history of, I don't know, think, oh, things just aren't good, and we're not there yet, it's too hard, things are too hard, right? And we've always had this thing where it's like, back in the day, it's like, I'm trying to design websites, but I've only got 216 colors, wah, right? Or I want to make a website, but I've only got these system fonts. Everything will be great once we can use whatever fonts. Everyone would be great if people would just upgrade from Netscape 4. If people would just upgrade from i6, then everything's going to be fine. If those Windows XP users would just upgrade, and everything will be absolutely fine. Once those Android version 2 users upgrade, right, we're never happy, right? There's always something. There's always something we're complaining about. My friend Frank, he wrote this essay a few years ago. It's called There is a Horse in the Apple Store. It's really good. And in it, he describes the true story of being in the Apple Store and seeing a tiny horse in the Apple Store. And he describes the tiny horse, and he describes his reaction to the tiny horse, but he also describes the reaction, or complete lack thereof, by all the people in the Apple Store looking at the shiny things. It's like, there's a horse in the Apple Store. Does nobody else see this? All right, there's this thing that's right in front of our eyes, and yet we're not seeing how amazing it is. And he's taken to calling things like this, tiny ponies, basically. And I think that the World Wide Web is a tiny pony. It's right in front of us. It's immensely powerful, and we're missing out. Right? We're not realizing. Instead, we're complaining like, well, I can't get 60 frames per second scrolling. Well, it's like, no, look at the power of what you have in your hands, the reach that you get from the World Wide Web. And frankly, it's not from the HTML, and it's certainly not the hypertext transfer protocol. It's this. Right? We're constantly comparing the web to other things, whether it was CD-ROMs, then later it was Flash, and now it's native apps. And we're always saying what those other things can do that we can't yet do on the web. Oh, and we don't realize what only the web can do. Right? What the real superpower of the web is. And I think it's here in the URLs. Right? Instant distribution. Somebody can click on a link, type it into a web browser. Heck, you can write it on a Post-it note or stick it on a poster, and somebody can install your service right there in their web browser. That's amazing. That's so powerful. Right in front of our eyes, and yet we're not realizing it. And the great thing about URLs is they extend over time. It's not like this one-time thing. Like that a URL can last, right? Cool URLs don't change. That over time, we can spread knowledge. We can keep it for future generations. That we can extend the reach of our network for future generations. Extend the reach of the collective knowledge of our species. And I think we should embrace that. We need to be good ancestors and leave behind a web that lasts, a web that's resilient. Thank you.